Next up is Optipulse.
Hi, my name's John Joseph. My team is basically some guys out of the national labs that optimized a lot of photonics many years ago, and now we're in commercial space. We have created a new type of light source, which is based on lasers which are used behind every fiber optics called a VCSEL. So I'd like to tell you why this is really advantageous for free space optics communications in space. Basically, the requirements for space are high power with energy efficiency, high bandwidth, single channel, high bandwidth with multiplexing, divergence control of the beam, low C-swap, which is cost, size, weight, and power, capable of radiation hardness, and non-mechanical beam steering is what we can do with this. So this chip that you're looking at right here is what we produce. We can produce this 20,000 of them on a single wafer, and I'll show you what it's capable of. Let's go to the next slide, please. So the advantage in this design is being able to take an array of these VCSELs and add them on a wafer scale so that they come out as a single beam. VCSELs in the past have always had low power, and that's why you had to put them into a fiber to get optical signals go over long distances so you don't lose the power. We are able to make much higher powered devices for wireless communications and sensing, LiDAR, light detection and ranging. Let me talk about, let's go back just for a second. So you can see the pictures here. The left side, the green part, is actually the lasers. You can't see those with your eyes, but they put out quite a bit of power. And the other side is where the lenses are etched into the gallium arsenide substrate. With those lenses etched in, a lot of our IP is how we manipulate those lenses in their locations to be able to add all of the beams together so that a macro lens can project that into the far field with a uniform power density and uniform bit error rate. Let's go to the next one, please. So our CTO is world renowned in VCSEL design, epitaxy design. My expertise is in processing. So his designs lately are world record in power and speed. So that the interesting part about this device is it acts like a laser, but it's actually a low coherent optical source. And that means it can go through the atmosphere much easier. The other advantage to this type of design is that 105 VCSEL lasers on one chip is just as fast as a single laser. Let's go to the next slide, please. And this is just to give you an example, that little chip on your finger there, this is the test of it. It's a 0.4 watts of optical power. That is enough to go kilometers of distance this system is 10 gigabits per second, but it's limited by the electronics. So we can basically make that chip for $1 in production. Let's go to the next slide. This interesting, the way that the lenses are, brings up all kinds of interesting use cases and applications. We can put multiple chips on the, put multiple chips on the substrate and be able to basically control each one of them, allowing very high multiplexing, way over the speed of a normal device. That group of text you can't see in the right-hand corner is our patents. We have 8 issued patents. We have quite a few pending and quite a few PCTs in this area. Let's go to the next slide, please. So With the design of this, mainly all kinds of designs can come out of this, but you can use all of those designs on a single wafer, which really allows it to be very inexpensive in developing different types of applications. Again, there's 20,000 of those chips on a single 4-inch wafer. Of course, it's been very costly to develop a compound semiconductor device that is world record in power and speed. But we've done it, and it's we're experts in that field. Let's go to the next slide. So there's a lot of applications with this kind of light source. It's basically infrared, so it's invisible. It has different spectral output, so it's not as dangerous as a laser is for your eyes. Many applications like self-healing moving mesh networks are possible with this. Vehicle-to-vehicle sensing and communication, parameter sensing, range finding, terrestrial and space, earth-to-space communications, data centers, directed energy in sensing and communications. So we can do quite a bit with this, and as you can see how small and energy efficient it is, it will make a big difference in space. So let's go to the next one. We're about to open a CF round, crowdfunding round in the next few weeks. And we're looking as a public opening to go at about $2 a share. Here's the details here. If we have a partner that can put in some larger round of cash, we're willing to take the value down. So we can discuss that if you're interested. So let's go to the next slide, please. Our team is, 3 of us worked together at the national labs back 30 years ago, developing VCSELs and optimizing them for fiber optic use. As a matter of fact, there wasn't fiber optics while we were developing these devices. So we have a very expert team in this round. Let's go to the next slide. And there's quite a bit of use cases here for this type of technology. I would like to just leave you with a couple of very important points. The reason why this technology is so important is because you can take very low power, fast lasers and make them a high power single source. That isn't capable right now, so we are the leaders in that field. And I'll leave the rest of the time basically for your questions.
All right, John, I'll go first. And there's going to be a little bit of advice here first that then leads into a question. So bear with me for just a moment. Sure. You spent the majority of your presentation time telling us how you solved your problems, how you created your product. But you haven't really explained to me what problems. Just now at the end, you almost got there to explaining to me how you're solving customer problems, especially if you're going out for a crowdfunding round. That needs to be first and foremost. We are saving customers X number of dollars, X amount of weight, providing X amount of additional capacity. That has not really been well defined in this presentation. So kind of flip this around and talk to me about what your product does. Give me a specific use case of a specific customer. This airman, if for example, how does it change that particular airman's life, right? So help me kind of contextualize what the real value of this product is here. Now that we fully understand what the product is, but any crowdfunding stuff, you're going to have to really kind of flip that around and talk about the value to the customer first. So let's give me a little spiel about that.
Thank you. Yes, our first customers are 5G systems that need connection between 5G radio units. We are partnering with a number of telecommunications companies, and I apologize, you're right. This was really based on technology for space, so I didn't get into the commercial application. I just put up on the chat a link to the video for the crowdfunding, which explains those applications you just mentioned much better. And so I'd please go to that and click that link on. I think you'll be, those answers will be or those questions will be answered. So
Right.
yes, wireless communications is very important, and especially at high speed. So what right now, RF is only capable of doing about 1 to 2 gigabits per second at a lot, well, at a fairly inexpensive cost. If you go much higher than that, it gets very expensive and it doesn't go very far. 5G needs 10 gigabits per second in order to make those radios operate appropriately, and that isn't capable right now in a wireless device. There's a very expensive wireless device that they're testing at around $50,000. Our stuff will bring that cost down dramatically. And so that's what you'll see in our video. The video is mainly commercial, so we have a lot of details on that if you're interested. So wireless, also LiDAR, light detection and ranging, is a very important sensing application. My first company, based on a slightly different program, has had a product that is already been the only product qualified for the automotive tier 1 company for a LiDAR product. And that's the light source for that product. So in space, it's very important to have low cost, size, weight, and power for communications. And that one chip allows you to communicate at tens of gigabits per second at a very low cost, size, weight, and power. I hope that answered your question.
Yes, thank you very much. That was very helpful. And I understand kind of why you flipped the presentation for today's audience. But even though we're a space audience, we're always still worried about customers and revenue, right? That's first and foremost.
Yeah, absolutely. And I forgot to mention, we do have we've completed a successful phase 1 with the National Science Foundation for an optional wireless technology. We're going into phase 2. And we are in a phase 2 with a DoD component I can't really talk much about, but it's very exciting. We've got a number of other grants on the board, and we are looking for making some space here in the development world with the DoD.
Question. Thank you for the presentation. Regarding your range, this is for space-com, space, either Earth orbit or beyond. Does your range scales with power?
Yes, it does. There's 3 things in range which are critical. That is power, divergence angle, and basically the medium you're going through. So space can go very far. For instance, that little chip that I showed you on the finger has been modeled at a 1.5 kilometer length at 10 gigabits a sec. Well, 10 gigabits a second, the limitation there is the electronics. But we have actually made a system that has gone from building to building at a local community college with 10 gigabit per second uploads and downloads. That's our 3rd prototype, and our 4th prototype will be the actual product. Our first minimum viable product, which is a link for 5G wireless radios.
We're going to get
test this on a CubeSat as a tech demo.
We'd love to be in that talking range. We have just put in a SBIR with Eagle Point to NASA, basically to make some long distance, very long range, high power devices.
Wonderful. We're going to have a whole end on the last question and then move on.
Great, thank you, Josh. So just one question about the fundraising side of things. I remember on your deck you mentioned, I believe 40 million is your valuation. I'm wondering first where you got that from. Is there a certain comp that you pulled that from? And then additionally, I'm thinking about your fundraising going forward. You know, a lot of times with SBIR phase 2s and beyond, you can do fund matching from institutional venture capital. And so I'm wondering if just what your thoughts are about raising traditional VC dollars as opposed to crowdfunding.
That's a great question. The 40 million seems high. Remember, compound semiconductor research and development is incredibly expensive. So developing a world record device has been quite a challenge over the number of years. But we are able to lower that value point quite a bit with a larger sum of money. The crowdfunding that we're looking at, that's for hundreds of dollars types of investments. So there are other discount rounds involved in that. What we came up with was us to get to that number. Well, I'd like to discuss that with you if you don't mind at a later date. But I think I ran out of time. Is that? I apologize. Thank you for those questions, though, and I would love to talk to you more.
Wonderful. Thank you so much, John. Thank you, everybody, for questions.